So good morning. It's great to see people again for the final day here of the boot camp. I wanted to begin, as I normally do, with a retrospective on the previous day. So yesterday we saw a bunch of different types of material. Most of it was structured around one of three areas. Oh, thank you very much, David. Much appreciated. Yeah. Oh, that's great. So I began yesterday's material by introducing, with tremendous brevity, several modeling methods, the three supported by AnyLogic, system dynamics, agent-based modeling, and discrete event modeling, and made some comments on their general features and the different perspectives that they bring to bear on modeling issues, the types of questions for which they're particularly used. And I noted that I have a set of material online, quite a few talks. One I'd recommend particularly that was given in Australia, you to particular areas of modeling space where one rather than the other would offer the most promise. I noted, however, that it's important to recognize that when it comes to the particular platform we're talking about here, AnyLogic, what's notable is that rather than having to commit to one method up front and persisting with that method through the duration of the modeling project, there's flexibility afforded to you because you can, within the same package, shift between methods, or more notably, you can expand certain areas of your model to use one method while other regions of your model use another method. And that flexibility has value. We know through real options theory that flexibility offers, in some situations where there's uncertainty involved, particular value, and so it is with this case. And in my observation as a modeler, being able to nimbly choose the appropriate method after learning about the situation can really be very powerful. Often the early learning brings to bear a set of recognition of a set of trade-offs and a set of features of the situation that might not have been obvious up front. I'd give as an example for this a project which we undertook for our Ministry of Health as a smaller project, a sort of pilot project, starting last February of this year, and where we initially took a system dynamics method. We built a top set of models that have been previously contributed, most notably by Jeff McDonnell in Australia, and secured a fair bit of insight from that. But the more the discussion progressed, the more the discussions with the clinicians involved and other health professionals that were part of the team, it became obvious that there were a set of intervention issues and a set of requests for understanding what was going on in the model that weren't fully spoken to by the system dynamics model. And that's within a based and discrete event model that captured those components of the situation. And so the learning that had gone on with the SD model was able to inform some innovation that went on in bringing several other methods to bear as well for the project. And that secured a lot of insight, a lot of buy-in, and a lot of interest on the part of stakeholders in continuing the project. And this is now going to be a much larger and more long-lived project. They're doing a permanent hire in this area to continue it with our Ministry of Health, and some top quality candidates are being recruited. So this is a situation where the choice of the method was not obvious from the start, and where it took a couple months of exploration to really have a good understanding about which areas of the problem were best recommended particular methods. So we took a look in this light at several types of hybrid models, and I think we went through 5 5, maybe 6 models, where we took a look at different configurations of interfaces between the 3 methods. So we looked at models where we had system dynamics within an agent. Perhaps the most prosaic of them being agents who were statically located in space, is capturing a certain region of space in a rectangular grid where there was flow between these different regions of space. I'll show you a very stylized model to help highlight for you the essential features of the situation, but we have a West Nile virus model which makes use of that basic approach, with a far more articulated model associated with West Nile virus dynamics. We also looked at a model where there's a network of agents, each of whose evolution was described jointly by a system dynamics model and by a state chart. So state chart capturing mortality, and the system dynamics model capturing continuous dynamics where the state variables on the part of an agent, those aspects of an agent that capture their current status, were varying continually rather than in a discontinuous fashion. So rather than jumping between states that are categorically defined, we instead had people vary continuously. And there's several other models of that sort that we have contributed to the literature. And if people are interested, I could give you some references. We then took a look at a different type of configuration of the multiple modeling methods with respect to models that also brought together agent-based methods and system dynamics methods, but in a very different way. So we saw, for example, a health economics model where we had agents circulating in the population, and system dynamics stocks and flows were being used to declaratively specify to sort of accumulate over time things like quality of life, to form quality adjusted life years, things like the cost, etc. So here we had agents at a low level and system dynamics at a high level. Yet another model joining system dynamics and agents had that we actually built up had agents coming out, as it were, from a flow in system dynamics, and as part of that model, Maria here had made a very nice suggestion of the possibility of capturing it rather than capturing it on sort of a fixed time schedule basis as to when people appear. Could you actually have it triggered based on a condition? I wanted to revisit that issue because the elves worked last night, or perhaps I should say Santa Claus worked last night, and I found that actually that method worked very well. The key aspect of it that was missing, and this is a point of note, is that when we have an event set to go off on a condition, we can have it fire based on this condition, and it fired fine one time, but it wasn't firing again. And I investigated why, and indeed, just a simple test confirmed that what you need is called to restart the event at the end of this method. So in other words, these condition-based events, you'll have to reset them to essentially set them looking for that condition again. After you've handled it and the condition has, in this case, disappeared, after you've lowered the number of people in the diabetes stock by the number of agents you've created, you can then reset the condition and it will be primed to go off the next time it happens. So it was just this key line, this restart, that was needed yesterday to make agents to be budded off into full-blown agents, like Athena from Zeus's head. We go and we create them, and then we start looking again. We prime the trigger to go off once there's enough waiting to create. And this, although it's a continuous variable, this should really be greater than or equal to 1. So as soon as there's at least one full agent to be created, we go and we create those agents, that integer number of agents, and we start looking again. This is a simple stock and flow model that illustrated a different configuration of system dynamics and agent-based modeling. Here, individuating agents, creating them as individuals at the point of development of their conditions where there may be a particular interest, where we wish to capture historical information on them, aspects of their trajectory through care, etc. This is an approach that we had used in this more articulated model that I described to you, which was a tripartite model integrating together system dynamics on the one hand, agent-based model, system dynamics for upstream factors, for example, capturing the impact of upstream interventions in their immediate implications, agent-based models for those individuals who had developed diabetes, so developed enough in their continuum of progression that they warranted particular attention, and then a discrete event model that was capturing the aspects of the care process involved. This model to be presented at WinterSim this year. Here we have a tripartite model that makes use of the same basic mechanism illustrated in its most skeletal form using this model here. We also looked at other models that were hybrid in character, such as models where we had agents in a discrete event simulation going on at first within the broader environment and then within particular discrete clinics. And individuals could present for care at a clinic and flow through the delivery. There was the individual in the clinic, both at the time of presentation, they go and present at that clinic by doing a take at the entry point of that clinic. So you refer to the entry point, you say, take me in to the clinic. And then also when progressing through care in the clinic, those individuals were sent messages which indicated changes that affected their health status or their care-seeking status. This is a very powerful mechanism. Out in LA, I was involved in building up a little model like this, capturing dynamics of clinics that focused not only on fixing problems that had presented themselves, but addressing habits and behaviors that contributed to those problems in the long term. So they were very interested in behavioral counseling and classifying patients into several different categories according to the level of counseling and education involved, as well as care delivery. And a model like that met just the bill needed because it could capture representation. In our case, in Saskatchewan, that sort of model was of great interest in the case of our provincial ministry because of the high number of cases of frequent flyers presenting in emergency departments. Again, 40% being individuals with either mental health issues or comorbid conditions that come in, and that 40% meriting specific attention because of their impact on slowing the delivery of care to others, as well as the particular unique needs that they face. And by capturing it in this sort of integrated agent-based and discrete event model in that context, we could capture the unique care delivery that's provided for these different classes of patients based on their characteristics in general and based on their history. So that sort of integration can be very functional, and it can deliver a great deal of value. Now, what we saw, although it's a matter of implementation, it bears noting in the boot camp context that because of AnyLogic's design, and specifically because of AnyLogic 7's design, this weaving together of multiple types of modeling is particularly straightforward. AnyLogic 7 is a continuous time discrete event scheduler, and so you can weave in a system dynamics model that operates with one set of time steps with events that are at arbitrary time. Notably, within AnyLogic 7, all agents are also entities. They can be full-blown entities, so that every agent can now, in a transparent way, flow into a discrete event model. And B sent messages, for example, as part of it, or otherwise interact as an element of that discrete event model. So weaving together each of these three methods is particularly straightforward within AnyLogic, and within AnyLogic 7 in particular. The three methods being used together are not merely intellectually present fascinating intellectual opportunities, but they can really address combinations of research questions that are quite practical. Okay, so that was some aspects of hybrid modeling. We further went on to talk about sensitivity analysis. Yes. Yeah. Sure. Sure.
Do you have to take to create the agent
Yeah.
stock and flow? Do you have to remove them from the stock, or is that just because in that particular one you weren't interested?
Oh, that's a good question. In that particular one, it was an either or, in the sense that we weren't interested in capturing them in the stock and flow model after a certain point in their development. But it's an intriguing point that you could have just as here in this tripartite model, we had people who were agents at the same time as they were in the discrete event model. You could have people who are depicted in the stock and flow model at the same time they're individuated as agents for other purposes. And so I think that would be a perfectly reasonable strategy in some cases. In our case, we wanted to capture aspects of dynamics that whose characterization in a stock and flow model would have been difficult, but we could have captured other aspects of their evolution over time in the stock and flow model quite nicely that weren't captured in the agent-based side, and you might have been able to somehow gain insight from both sides. So I think it's possible. It's just one thing you wouldn't get is you wouldn't be able to track. So if we had, a stock and flow set of progressions and over here in the stock and flow model, and if agents became individuated sort of at this here, you'd be able to keep track, for example, as to whether a given agent that you had individuated at this point of transition, in which stock they would be currently located, without, capturing some sort of logic in here related to this. In other words, the stock and flow model it doesn't capture individual transitions, and so you wouldn't know, of the 1,000 people in stock B or the 2,000 in stock C at a certain time, is this particular agent, call it agent P, are they in B or C at a given time from the stock and flow model alone? Does that make?
Yeah, because it's a continuous flow, so it could be a half person or something.
It could be half a person, exactly, and there's no you can't in general, they're considered well mixed, so all those in B are sort of considered more or less interchangeable, and as such, we can't really meaningfully track, the location of the particular individual came into B at this certain time. Are they in B or C now? There's more of a probability distribution that they'd be in B or C now. Yeah.
Where people are like in states for a temporary amount of time. Like if you're tracking
right.
Women who are pre-diabetic or something, and then during pregnancy you want to be looking very carefully at the gestational diabetes.
Right.
But then when pregnancy is over, they could either return back to their normal state or have become diabetic.
Right.
After that, but only during that time.
I see. Beautiful. Yeah, that's really interesting. That's really, really interesting. Right. So during that time, you might want to capture them as agents and deal with aspects of their social context and deal with aspects of their micro sort of behaviors and in their history. But then they would flow back into, say, a non-pregnant state following that. That I could imagine that being very powerful. Yeah. Right. You'd have to like you could create a state chart in this person, let's say this woman who has gestational diabetes, representing the time of her delivery, right? And so when you flow into a gestational diabetic stock, that person is set up. It's individual. They're budded off as an agent, and they have this state chart which starts ticking for when they're going to deliver. And when that goes off, then this person was originally there. In the meantime, they're in this other stock. So I think that's really interesting, and I'd love to explore that further. Actually, a very very creative way of using it. Any other questions on hybrid models? Okay, so I provided a number of examples to you, only some of which we got to see yesterday. So we then continued on to a discussion of sensitivity analysis, and I noted that within the sensitivity analysis context, as well as the calibration context, which we'll be seeing today, rather than an experiment corresponding to a single run of a model with a particular random number seed, a single run through, a single main coming into existence and going out of existence at the end. Instead, now an experiment can be a more overarching entity where mains come and go as part of it. It's running multiple multiple times, running the model several times over, sometimes in parallel, concurrently, running these things, and reading data out of each as they run to summarize the behavior of the model over an ensemble of realizations, over a large collection of particular runs. And we do that to capture not just the impact of varying parameter assumptions, but the impact of stochastics within the model. And we saw how AnyLogic provides some graphical mechanisms in the form of, say, 2D histograms that allow us to summarize in a cross-sectional way over a large number of different realizations, model behavior, and others such as the histogram, which we added and showed that we could summarize information also over multiple replications using histograms. So sensitivity analysis was one of those areas which is a little bit intricate in the sense that you got to have a conceptual understanding of what's going on, and there's a bit of code needed to kind of make to rescue the appropriate data and make use of it in the experiment. But the tools provided are very very powerful and can spare you a lot of time compared to implementing it by yourself. Okay, so sensitivity analysis was a mechanism that made use of some returning to that for to do with how many parameters do you really need to vary and which parameters should they be, etc. And discussions that are still continuing here. Any questions? Okay, finally we ended with, for those who stayed for it, some discussion of Java statements, these sort of commands that can tell AnyLogic to do something terminated by a semicolon. And we started to take a look at these things called functions that we can introduce, which pack together a bunch of commands typically to actually accomplish some tasks and allow us to call them without needing to look at all the code. We could just call off to them for a request. We could ask them to perform a service for us. We could ask them, to perform a complex service, for example, to tell us whether a given person is eligible for an intervention, to tell us whether they have a certain property. And it could do a lot of work for us, but all we need to know is the name and what information it needs to do its job. And it will do the job for us and return us the appropriate indication or otherwise change things in the way we desire. So those were functions that we covered in the latter parts of our Java tutorial. So any questions about yesterday before I go on to new material? Question? Yes.
I just wanted to ask, are you going to talk about how to transfer data to the spreadsheet?
Yes. That's one of the things we'll be doing this morning. Yes. It's on the docket. Anything else? Okay. So, what else is on the docket for today? There's a lot of things on the docket, whatever a docket is. I'm not quite sure. I think of it as kind of like a loading dock, but I'm sure I stand to be corrected. So let's talk. I'll switch over, and we're going to nuggetize